Okay, so today we're going to talk about 4.3. We're going to do angle relationships in triangles. Most of the stuff you already know, but we're going to go through it. Okay, so let's look at page 231. On page 231, there is a theorem there. Theorem 4.3.1 says the sum of the angle measures of a triangle is 180 degrees. Okay, we all know that, right? We all know that if you add these three angles, angle A plus angle B plus angle C is equal to 180 degrees. We know this, right? We've learned this. We've had this before. We've done this in algebra. Okay, so we know we've done this in pre-algebra. So we know all this. We know that when you add the three angles in the triangle, it's 180 degrees. Okay, so let's go to example number 1, see if we can utilize this and solve example number 1. This is on page 232. Page 232, example 1 says, the map of France commonly used in the 1600s was significantly revised as a result of triangulation land survey. The diagram shows part of the survey map. Use a diagram to find the indicated angle measures. Okay, so it looks like we're trying to find NKM. And so if you look at it, we have KM. And we're trying to find this angle right here, this guy right here, where we are given 88 here and 48 here. So this angle is going to be what? Nothing more than 180 minus 88 minus 48, right? So that would be what? 92, 44 degrees, I guess? 44 degrees? Okay, 44 degrees. And then they want us to find this guy here. Okay, so they want to find this guy. They want us to find this guy right here. When we know that this is 104, this guy here is 104. And we know that this guy here is 70. Okay, so we need to find this guy here. In order to find that, how would we find that? Do we know anything that's parallel or anything like that? No, we don't. So we would have we would have 104. This is 44, right? So if you add those together, you get what? 100. And so this is, okay, so here. This guy here was 44. This guy here was 44. This guy here was 104. So this guy here, right here, is going to be what? This is going to be 180 minus, if you add those two together, it's 148. So we get 32. Right? So if you get 32 there, and then we have what? 32 plus 70 plus this guy here is going to be what? So we can find JLK, which is this guy over here. Okay, this guy here is going to be what? 180, since we found this is 32, minus 70 minus 32, right? So this guy here would be what? 102, that would be 78. So this would be here 78. So that's 78, which means that JLK would be 78. And that's what we're trying to find, right? We're trying to find JLK. We're trying to find this guy right here. JLK right here. Okay. So we basically use this, that these three angles added together are 180 because they're on a line. Okay, so we had 44, we solved this earlier. So we have 104 plus 44, we have 148, which means that this guy here would be 32. Now that I know these two angles add to 102. If I subtract that from the 180, I'm going to get this guy here, which is 78. Okay, so that's how that went. Now let's look at the corollary. There's a corollary down there. A corollary is not necessarily strong enough, something as important as a theorem, but basically it's a byproduct of a theorem. Okay, that's what a corollary is. Okay, so we have a couple of corollaries there. On the bottom of page 232, we have 4.3.2. Says the acute angles of a right triangle are complementary. Well, that makes sense, right? Because we have two angles here. We have the right triangle. I know this is 90, which means that this guy here plus this guy has to be 90. So if they're add to 90, we call that complementary. Okay. Just as a review, if they add together, they are 180 degrees. What do we call that? Jose, what is that called? If you add together and they're 180 degrees?
180.
Huh?
Supplementary.
Correct, they are supplementary. Very good. Okay, they're supplementary. Okay, so these are complementary because when you add together, they are 90 degrees. Okay, and then the second corollary is the measure of each angle of an equiangular triangle is 60 degrees. So if they're equiangle with angular, means that all three angles are the same, right? So if I have three that are the same that add to 180 degrees, I will just divide that by 180 by 3. And I can find that each angle is going to be 60 degrees, right? Okay, so that's good. So you don't get fooled when it says equiangular, right? Equiangular is also what? If you look at the legs have to be the same also, and so they are called, or the sides have to be the same, which means they are equilateral also, right? Okay, so let's look at example number 2. Let's get example number 2. One of the acute angles in a right triangle measures 22.9 degrees. What is the measure of the other acute angle? So I have two acute angles. This is a right angle. And this guy here is 22.9 degrees, which then what is the other one? So we're trying to find this guy. So this guy would be what? Since these two have to add to 90 degrees, they're complementary. This guy would be 90 minus 22.9, which would be 67.1 degrees. Okay. And the middle of page 233, I'm sorry, there's a theorem 3.3-4, exterior angle theorem. Exterior angle theorem. Okay, this is kind of interesting. Okay. This says that if I have a triangle, it looks like this. This angle 1, angle 2, angle 3, and this obtuse angle 4. Okay, what they're saying is that angle measure 1 plus angle measure 2 is going to be the same as the angle measure 4, or what we call the exterior angle of the triangle. It's called the exterior angle of the triangle. Okay, so how do we solve that? How do we find that out? Well, angle 1 plus angle 2 plus angle 3 is a triangle, A4 triangle, so that's have to be 180 degrees, right? But also angle measure 3, right? Angle measure 3 plus angle measure 4 is equal to, because it's on the line, they're a linear pair. Their linear pair is 180 degrees, right? Okay, so from here you can see that these two and this have to be the same because they both add to, if you add the 3, they become 100. In other words, if I went ahead and subtracted both sides, I'm going to get what? Angle measure 1 plus angle measure 2 minus angle measure 4 This guy cancels out. This guy cancels out. It's going to be equal to 0. Right? So I move this guy over on the other side. I get angle number 1, angle number 2 is equal to 4, right? Just as we talked about, right? So this is how the exterior angle theorem works, okay? The exterior angle theorem, okay? And realize that you can also put the exterior, each angle has different exterior angles, right? I can go like this. I can put the line down here, right? Then I would have an angle, I'll just call this 5, just to distinguish between the 4. Angle number 5 is going to be equal to angle number 1 and angle number 2 added together. Okay, because this is the exterior angle associated with these two angles. Okay. Okay, let's look at example number 3 and see if we can do that. Example number 3. Applying the exterior angle theorem, find angle J. Angle J, you want to know what angle J there is? I have two interior angles that add to an exterior angle of 126 there, right? So I have 126 is equal to 6x minus 1 plus 5x plus 17. Okay, so I would combine the like terms here. I get 11x. I have the minus 1 plus 17, so it's going to be plus 16 is 126. Move the 16 over. You get 126 minus 16 is 11x. This is 110. So I divide both sides by 11. This guy goes away. I get 10 here. So x is equal to 10, okay? Now be careful here. Sometimes the question asks just for x. Sometimes it can actually ask for the angles themselves, right? So let's see what it says. It says find the angle J. So I have to find angle J. So just because I found x doesn't mean I'm complete here, because angle J, angle measure J, is equal to 5x plus 17, 5x plus 17. So now I have to put this in here. So 5 times 10 is 50. So the angle measure J is 67 degrees, okay? 67 degrees. All right, let's flip the page, go to page 234. There is another theorem there, yet another one, 4.3-5. Okay, let's go ahead and read that. It says, if two angles of one triangle are congruent to the two angles of another triangle, then the third pair of angles are congruent, okay? Third pair of angles are congruent, okay? Which makes sense, right? Since the three of the angles have to add to 180 degrees, if the two are the same, the other one automatically has to be the same too, okay? All right. One thing to make sure you understand here, we're talking about angles only, okay? So triangles don't necessarily have to be congruent, right? Because you can have the same angles, right? The same angles, and you can have different triangles. You can have this angle is the same as this angle. This angle is the same as this angle, and this angle is the same as this angle, but they're not the same triangles. We call, what are these triangles called? Ben, what are these called? Anybody? What are these angles called? What are these triangles called?
Sorry, they're equilateral.
No, they're not equilateral. Equilateral means all three sides are the same. These sides are not the same.
Dilation?
Okay, you're close. You're getting close. They are a dilation of another. Okay, that's good. But that's not
They're
what we call this.
They're scalenes.
They're both scalene because they're all acute angles. We call
They're
them similar
congruent.
angles, similar triangles, right? They're similar. They're not the same, so they're not congruent, but they're similar, right? Okay, they're similar. Okay, so if I had angle A, I mean this is ABC, this is triangle FGH, I would say that the triangle ABC is similar to the triangle FGH. Okay, so this is the notation we would use for similar. Okay, just giving you a heads up. We're going to learn this here pretty soon. Okay, we're just kind of giving you a heads up there. Okay, all right. So that's what similar triangles are. So let's see, go to example number 4, applying the third angles theorem. Find angle measures C and F. C and F. So we have triangle ABC, where this is a right triangle. Then we have here EDF. Okay, so we have angle C here is Y. And we have this angle here is 3y squared minus 72. Okay, and I've been told that this angle and this angle are the same. Okay, so these two are, this is 90 degrees, these two are the same, which means that the other ones, the other ones that are left, these two have to be the same. So we're going to get 3y squared minus 72 is equal to y. Okay. Oh, this is y squared. I'm sorry, y squared. Y squared. Okay, so I'm going to move this y squared over. I get 3y squared minus y squared. Move the 72 over here. I get this. So I get 2y squared is 72. Y squared is equal to 30. Y squared is equal to 36. Y is equal to plus or minus 6. Okay. So what's the question? The question is, we needed to find angle C. Angle C here is 36. So this guy here is 36. Okay. So let's make sure that this guy is 36 too by, we would say, since I know that y squared is 36, I have 3 times 36 minus 72 here. If I put that in here, 3 times that is 108. So if I get that, I do indeed get 36. So either one of them is 36 degrees. They're both the same, okay? They're both the same. Thanks. Okay, so we are done with 4.3. Are there any questions there? Any questions that I can answer?